Welcome everybody to the 2017 Calculus BC FRQ exam. In this video, we're going to be going through questions 1 and 2. This portion of the exam requires us to have a calculator, so get your calculator ready. If for some reason I go too fast or there's something you didn't understand, let me know. Make a note of it on your practice test. Jot it down and let me know in class so I can help you guys out. Okay. Number 1, we have a particle moving and we're given the position vector. Okay. Find the speed of the particle. Okay. If you want to find the speed of the particle, first, make sure that you know your formula. And it's going to be x prime of t squared plus y prime of t squared. And of course with the square root. You do not have to find the derivatives by hand, right? You can use math 8. You're going to take the derivative d dx at x equals 2 of sine of 2x with the calculator, and whatever number you get, that's what you get. Then you're going to take the derivative with respect to x at x equals 2 of x squared minus x, and whatever you get, okay, you're going to use it, because then you're going to go plug it in to your formula. You're not taking the derivative of the formula. You're taking the derivative of x and y and then getting those values to use in the formula. Since you're using the calculator, make sure that you're using all the decimals. Right? You can copy and paste the decimal. Don't be rounding in this case, because if it's off, you might not get the point. But the answer here is going to be 3.272 meters per second, because it is a derivative. And put a sentence just in case. The speed of the particle at t is equal to 2 is 3.272 meters per second. Okay. You know what? I should have the rubric available with me so I can tell you guys. So I can tell you how many points this is worth. So give me 1 second. Let me see. 2017 practice test. Okay. So question number 1, part A, is worth 2 points. You're gonna get 1 point for having the correct formula for speed, and you're going to get 1 point for the answer with the units. Okay, so let's make sure we're training that, setting up the formula and showing our work step by step. You don't get any work for this. I think it's kind of assumed that you're going to do it with the calculator. Okay. Is the speed of the particle increasing or decreasing? Speed, increasing, decreasing. Anytime you want to figure out if something is increasing or decreasing, you got to get its derivative, right? So speed, derive speed is the square root of x prime of t squared plus y prime of t squared. So let me see. In this case, we are actually going to have to take the derivatives by hand. So your x component is sine 2t, but your derivative is going to be 2 cosine of 2t when you use the chain rule. Your y component is t squared minus t, but the derivative is 2t minus 1. So that means the speed formula is going to be 2 cosine of 2t squared plus 2t minus 1 squared. And that's an equation for speed. Now you can find the speed at any given time. But we want to check if this is increasing or decreasing. So you're going to take your derivative. ds dt at t is equal to 4. So in other words, you're going to be using math 8. Math 8, you plug it into your calculator. Make sure you plug in the equation at x equals 4. The calculator uses x's, not t's. And you're going to get 2.163. So is the particle speed increasing or decreasing? Well, the speed of the particle is increasing at t is equal to 4 because s prime of 4 is greater than 0, or it's positive. Oh, for this question, we're going to get 1 point by actually being able to take the derivative of the speed function as 4. And we're going to get 1 point for your answer with the reason. And you know what? Actually, looking at the rubric more carefully, just trying to take the derivative of speed gives you the point. You get the other point by forgetting the answer with the reasoning. That's the second point. Find the total distance traveled. Well, I hope you guys know your formulas, because if you don't know your formulas, you're going to be stuck. It's the integral from a to b of the square root of x prime of t squared plus y prime of t squared dt. Don't forget the dt. Oh my god, I've been writing dt's and dx's so many times in your guys' FRQs. So write it down. The integral from 0 to 5. You don't even have to write what x prime and y prime are, but we did get them in the previous question, right? Just so you know. But I'm going to keep it as x prime here just for simplicity. dt, don't forget it. Okay, you plug it into your calculator, we get 22.382. So the particle travels 22.382. What were my units? Meters. During the first 5 seconds. Back in AB, we learned total distance traveled by taking the integral of the absolute value of v of t. And technically, you don't need the absolute value here because we are squaring. We're squaring x prime and we're squaring y prime. So even if they were negative, that square would make them positive. So the absolute value is not necessary. Part D. Oh, it looks like I already have something. Maybe one of you guys asked me a question about this. At t is equal to 8 seconds, the particle begins moving in a straight line, and it travels with the same velocity vector that it had at 8 seconds. Find the position of the particle at t is equal to 10. Okay, so you already see my formula there. We're going to have to use it. First, since the particle travels with the same velocity vector that it had at time 8, let's find the velocity of the x component at 8 seconds. X prime was 2 cosine of 2t, right? So x prime of 8 equals 2 cosine of 16. Y prime, the velocity vector was 2t minus 1, 16, 15. That's the velocity. At 8 seconds, the particle hits this velocity, and then it maintains this velocity for every second after that. We want to find the position of the particle at 10. So we should probably find the position of the particle at 8 seconds. X of t was sine of 2t. So that's my position for the x component. The y component, that was t squared minus t. That's going to be 64 minus 8. That is 56. That is the position that we had at 8 seconds. So if I want to find the position at 10 seconds, we're going to do the integral from 8 to 10 of the velocity. But again, because the particle has the same velocity, it's just going to be 2 cosine of 16. It's best to use this and not round. Dt plus the position of the particle at 8 seconds, which is sine of 16. Then for the y component, we have the integral from 8 to 10 of the velocity 15 dt plus 56. And if we did everything right, which we should have, we're going to get that the particle has a position of negative 4.119, comma 86. That's the position, is the position of the particle at 10 seconds. T is equal to 10. Number 2. Oh, again, some of you might have already asked me a question about this, so let's start fresh. Water flows into tank A at a rate of A of t liters per hour. During the same time, water flows into tank B. We don't know the rate, but we know it's liters per hour. Both tanks are empty. Sounds like an initial condition to me. How much water will be in tank A at 4.5? Well, if you want to find any sort of quantity, we're going to have to do an integral from A to B of A of t dt. There was no water at the beginning, right? The tank was empty. So we get 66.532 liters of water in tank A at 4.5 hours. Okay. Oh, ignore this. Ignore this. Okay. During the time interval from 0 to k, water flows into tank B at a constant rate of 20.5 liters per hour. That's my rate, all right? B of t is the rate, 20.5. Just because it's a number doesn't mean it's not a rate. Okay, so what's the difference between the amount of water in tank A and the amount of water in tank B at k? What the heck is k? The graphs of A and B, they intersect at k. Look at that right here. This is k. And they also intersect at 2.416. So we're trying to find the difference in water in the tanks from 0 to k. So even if I don't know what k is, I can tell that tank B has way more water, right? Look at all the water tank B has. Look at that. Tank A only gets this much water. So here's my setup. Integral from 0 to k. We said B has more water, right? Of B of t dt minus the integral from 0 to k of A of t dt. We just need to figure out what k is. And we were told that A and B intersect. So A of t should be equal to B of t. Oh, I'm using capital. So you're going to take your graphing calculator and try to figure out when this equation plus 5 E2 sine of t equals to 20.5. But if you're going to find something like this, it's always best to set it equal to 0. It's going to increase your probability of seeing the solution on your window. Because if these graphs intersect at some really crazy value, you're not going to see that. You're going to have, you might be thrown off. But here we're looking for the x-intercept. Second, trace 0. And that happens at t is equal to 0.892. So the integral from 0 to 0.892 of 20.5 dt, and is the integral from 0 to 0.892 of a of t, I don't want to write that whole thing out, is 10.599. That's the difference of the amount of water between the tanks. When you're doing the actual AP test, make sure you don't go past this border. Like it literally tells you, do not write beyond this border because that's probably not going to be graded. So really careful with that. It's the difference of the amount of water between the tanks from 0 to 0.892 hours. And just so that it's clear, B has more water. Oh, maybe I should just talk through this since I already have my work. That way I don't have to erase it. The area of the region bounded by the graphs is 14.470. How much water is in tank B? So they said that the area of the region bounded by the graphs is 14.47 between K and 2.4. So that tells me that's this one. How much water is in tank B? Well, tank B is this, right? We're trying to figure out all this quantity because we're trying to figure out how much water the tank has after 2.416 hours. So maybe I should erase my work so you guys can see it fresh. Nah, let's just go ahead and do it. Look, I start with my first integral right here because I want to figure out how much water is in tank B. I don't overthink it. I just do the integral from 0 to 2.4 of B of t dt. But then I have to chunk it up into two intervals. The first interval, this interval, I actually know what B of t is. B of t is 20.5, and I already know what K is because we figured it out earlier. So I can just calculate that, right? I can just tell you, hey, the integral from 0 to K of 20.5 dt, and I didn't finish writing it, so I might as well finish it. Remember that K is like 0.89. So when you do this with the calculator, you're going to get 18.287. But that's just the first part. That's just this part. That's how much water there is there after that many hours. Now the second part is a little more tricky because the second part is this guy, and now we don't have an equation for B of t. But what we do have, look, here's the second part that I'm trying to calculate. I don't have the equation. But we do know the equation for A. So if I find how much water was pumped into tank A from K to 2.4, and then I subtract the area, I'm going to get how much water is in tank B. Watch, let me show you. I'm trying to find all this area in tank A, right? From K to 2.4. But if I subtract the 14.47, I'm left with the blue area. So the integral from K to 2.4 of A of t minus 14.47, that gives us 30.027, which gives us 48.314 at t equals 2.416 hours. Tank B has 48.314 liters of water. Okay. Okay, during this time interval, the rate at which water flows into tank B is given by this. Oh, now we have an equation. Okay. Is the difference increasing or decreasing? I feel like we recently talked about something like this, right? If you want to figure out if something is increasing or decreasing, you got to take its derivative. So the difference, is the difference increasing or decreasing? So let's derive it. If we derive it, we're going to get W prime of t minus A prime of t. Don't worry about actually doing it by hand because we have calculators for that. Then you're going to plug in your 3.5. Use your calculator. Math 8. You won't have to find the derivative. The calculator is going to derive it for you and it's going to evaluate it for you. And when you do that, you're going to get negative 1.143. So since the difference, here, it's not 51, it's 5. That was a parenthesis. That was an ugly parenthesis. Minus A prime of 3.5 is negative. The difference is decreasing at t equals 3.5. Perfect. And I'm going to give you one more suggestion. Even though I got an actual answer for my difference, notice how I'm just saying the difference is less than 0, because that can get us a point. Even if this is wrong, we can still get a point for the interpretation. Because I'm saying, hey, I have a negative number for my rate. That tells me the difference is decreasing. We can potentially get a point for that, as long as you keep it in the way. As long as you keep it specific, but vague enough. A specific vague. Yeah, give me a specific vague. So there you go. Oh, but just by the way, this was not wrong. Just in case it was wrong. Yeah, that covers the first 2 questions. Next time I'll see you for part B, where we are going to work without a calculator. Thank you very much, ladies and gentlemen. See you then.